Our project is titled Subtrack. It's a subscription management system. The team members are Vashita Satish and Sanjay Bhaskar. Let's go ahead with the project goals. So the project goal of the Subtrack system is to simplify subscriptions by providing a user-friendly cloud-based platform for tracking, predicting, and managing recurring expenses. We have integrated the Plaid API to securely retrieve subscription-related financial data from users' bank account, allowing for seamless data addition and review. Uh, our platform features an interactive dashboard to view, edit, and manage subscriptions. An email notification system alerts users of upcoming payments and renewals with built-in error handling for failed deliveries. To ensure scalability and reliability, we have hosted the system on Google Cloud Platform with auto scaling and load balancing enabled. Let's go ahead with the software components of our project. So for front end, we use React.js for a responsive user interface. Backend, Node.js with Express.js for server-side logic. Database is MongoDB. Deployment, Docker and Kubernetes. Monitoring, Google Cloud and Prometheus. Let's get started with the hardware components. So the virtual machine that we have implemented uses E2 standard 2, and the region is US Central 1, and zone would be US Central 1B. This is the VM that we have implemented for our project purposes. Architectural diagram. So the user accesses the React.js frontend to manage subscription. Requests are routed through a GCP load balancer for fault tolerance and distributed to backend instances. The Node.js backend interface with MongoDB to fetch, store, or update, and interacts with the Plaid API to retrieve the subscription information. Automated email notification are handled by NodeMailer, while GCP's Cloud Scheduler triggers reminders. Let's go ahead with the interaction between components. User interacts with the frontend to add, edit, or review subscriptions. The frontend sends requests to the backend, which validates the data, processes the business logic, and interfaces with database or external APIs. Autoscaling ensures performance during high traffic periods, and the load balancer distributes the incoming requests for to make sure that their fault tolerance is enabled, or it makes sure that everything works properly between the nodes. So yeah, that's how the components interact with each other. Debugging and testing mechanisms. We've used Google Cloud logging, Plaid API logs to trace and resolve issues. Crash reports with automated alerts help to identify a few other issues. So for testing mechanism, unit testing was API endpoints were validated using Jest, Supertest, and they've also used Postman to test the APIs. For integration testing, we ensured that proper interaction between the front end, backend, and Plaid API was done. We have used Locust for load testing, where we have done multiple API calls, and we made sure that the app could kind of like handle multiple requests at the same time. So that was done using Locust. Working system and bottlenecks. So few of the potential bottlenecks would be database query complexity during peak loads, and we are heavily dependent on Plaid API in this project, so that kind of slows down the system at times. And network latency for users who are far away from the GCP data center. So that are a few of the potential bottlenecks. Learnings. Embracing architectural changes from the initial plan is crucial for project success, because we initially thought of integrating Firebase, but later shifted to MongoDB. So we had to incorporate all of these changes. And then we prioritized local testing before deployment to ensure robustness. We used log levels in order to quickly diagnose the issues. Project synchronization by Git pull frequently to avoid merge conflicts was again one of the learning from the project that we have currently implemented. And that's about it. Thank you. Sanjay is going to go ahead with the demo now.
So let's just now let's get started with the demo. This will be the login page. I'm gonna log in using my credentials, which I already registered with the application. So once a user logs in, he will be directed to this tab where he's asked to link his account. So I'm gonna link my account, select the bank, continue to log in, and he will be redirected to a pop-up where he is asked to enter his bank details to like connect his bank account to the application. So we have already created a custom user who replicates an user with his own set of transactions and subscriptions. We are gonna use that for the demo purpose. Now enter the username and the password, sign in. For now, let's skip all of these, select the account which I wanna connect to the application, give the permissions, connect, accept the terms and conditions. So now it's successfully connected to our application. And then the application says transactions and subscriptions pages are now available since we are able to get the information from the user's bank account. If I click transactions, the application's gonna fetch all the transactions from the user and is gonna display it. And these are the transactions which the user has done. This will be the transaction name and the amount, followed by the date, and it also displays the category which the transaction belongs to. And from this transactions list, we are gonna pass and find what are recurring transactions. So, and that will be displayed in the subscriptions page. So in the subscriptions page, we can see that all the recurring transactions have been collated, and we also tell the user when's the next payment due. And there is also manage subscription button, which sends the user to the actual subscriptions account page so he can manage the subscription. We also have implemented a send email functionality. When clicked, it compiles all of the subscription and sends an email to the user. I am gonna share my email app. So this will be the email which we are gonna get from the user, which has all the subscription informations. Thank you.